All right, hey Algebra 2ers. We are kind of in the middle of the day 3/4 notes. So we did the first part talking about correlation coefficient and talking about how to run a linear regression and then answer questions based on it. So where we are picking up is with example 2, which is on, I guess, like the third page of the notes here. So I want to keep going by doing a couple more examples in here, right? So example 2 starts with saying, as a science project, Shelley is studying the relationships of car mileage in miles per gallon and speed in miles per hour. All right, so it's something we're pretty familiar with. Most of you guys are probably learning to drive right now if you don't know how to drive already. The table shows the data that Shelley gathered using her family's vehicle. Use a graphing calculator to create a scatter plot of the data, find a linear regression model, and graph the model. Then use the model to predict the gas mileage of the car at a speed of 20 miles an hour. Okay. So to be able to create the scatter plot, let's start from scratch how we would do this. You want to enter into your calculator list 1, list 2, and I always want my X to be list 1. I always want my Y to represent list 2. All right. And in this case, it should hopefully make sense that the mileage is going to be based on like the speed. Because usually I think it's like the slower you go, typically the better your gas mileage is. So like if you speed, you're burning up lots of gas, but you know. All right. Now in your calculator, depending on what you did last, you might have stuff in your list right now. So I want to talk first about how to clear out your list without deleting them. All right. To get to your list, you're going to go to Stat and then Edit. So Stat, Edit. So I have data values in there from the last time we were looking at these notes. To clear the list, I'm going to go up and highlight L2, hit the clear button, and then enter. And then go over to L1. So I'm highlighted on L1, hit the clear button, which is right here, clear, and then enter. Right? If you, by mistake, delete a list, we can reset your calculator to bring it back, but be very careful to clear the list and not delete it. All right, clear, 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 clear. All right, moving on. So let's type in what we got. So into list 1, we're going to type in 30, 40, 50, 60, 70. Go for it. All right, into list 2, put in the correlating values. So 34.0. 33.5, 31.5, 29.0, and 27.5. So you can see that the faster they're driving, the gas mileage is coming down, so it supports what we were talking about a moment ago. All right, to create a scatter plot, you can either pick your own window by picking the X minimum and maximum to match your data points. So I would need to be able to see from maybe a little less than 30 to a little bit greater than 70. So something along the lines of, maybe 25 to 75. And then you could set your own window for this, or I'm going to take advantage of the zoom stat to be able to see what's going on. So I have my stat plot already turned on. If you guys are ever in your Y equals, you can tell whether or not your stat plots are turned on by the fact that you're going to see that highlighted up top. If it's not highlighted, it means your plot's not on. All right. So I'm going to go to zoom and then stat. And here's exactly what I want to see. So let's draw a little sketch. It does not need to be perfect, but it does need to be labeled. So x-axis, that's our speed. Y-axis, this is our mileage. And basically, all I need to see is that it's doing a little something like this, okay? General idea of what you're looking at here. All right. So when it says, what do X and Y represent? We've kind of answered that, but we could say it again. X is speed. Y is our mileage. What viewing window are we going to use? Well, I cheated a little bit and I used zoom stat, which it's not even a cheat. It's a smart thing to do. But otherwise, this would tell me my X's. So from 30 to 70, this tells me my Y's. So I have to see at least as low as 27.5 up to 34. Okay. So this will give me a good window though. And if you want to, go and look. You can see if the window matches what we said. So yeah, 26 to 74 covers those X's. 26 to 35 covers those Y's. All right. what trend do we observe? Well, it looks like the higher the speed, the lower the mileage. So it looks something like this. So how we would say that is as speed increases, mileage decreases. So it's almost like end behavior. As this thing is happening, what's happening with that? All right. Or you could simply say that there's a negative slope as well. That would be another thing to observe here. All right. When it says perform the linear regression. Okay, so here's some more practice. So on my calculator, I'm going to go to stat and then over to calculate. And then we're going to choose choice 4 linear regression. So stat, calculate, and then choice 4. And I'll write it down here to remind you. So it's lin reg. Right? When you hit enter, it will always default to list 1 and list 2. So as long as you put the data there, you will never have to change that. And then you're going to calculate. Okay, so it's asking us to come up with the regression model. And it doesn't say where to round because we don't need to round. So when you look at this in mx plus b form or ax plus b form, this would be negative 0.175x and then plus 39.85, just like that. All right. The R value, I have negative 0.9828, and it keeps on going. That is really close to -1. So that's a really strong negative correlation, right? So when it says determine the strength of the relationship, that's what we would say is that there is a strong negative correlation between speed and gas mileage. What is not strong is the line. Please don't say you have a strong line. That's not a thing, okay? So the correlation between the data values, so between the speed and the gas mileage, there's a really strong correlation, right? They're highly connected, if you will, right? So when it says graph the model along with the scatter plot, all right, well, we already did that. We sketched that here. Now what we can do, though, is we can go into our y equals and type that equation in. So negative 0.175x and then plus 39.85 and then hit graph. And what you're going to see is it makes sense it's a strong correlation. All those points are pretty darn close to that line right there, all right? Last part, predict the gas mileage. So predict the gas mileage of the car when the speed is 20 miles per hour, all right? Speed is the X, gas mileage is the Y. So it's asking us to find the Y value when the X value is equal to 20. That is what this part is asking for. All right? So take your equation. This is the whole point. You're going to take that equation, plug in, and then calculate. All right. So right here, I can go to my home screen and I can do, whoops, a little calculation. So I can do negative 0.175 times 20 and then add, oops, sorry, add to that the 39.85. And I come out with 36.35. And now you got to think about what that is. That's the gas mileage. So the gas mileage is miles per gallon. So they're saying if you drive along slowly at 20 miles an hour, then you would use 30, or you could drive 36 miles per gallon, right? Now, something it doesn't ask for here, but it asks, I want you to think about, is this interpolation or extrapolation? So interpolation means that the value you're being asking about is within the domain. So when you go back up to the chart, if I asked you about any X value between 30 and 70, that would be interpolation. But 20 is outside of that. 20 would be down here. So this is considered extrapolation. Right? And the reason it's extrapolation, we can say, is because 20 is outside of the domain. Right? But what does that mean other than just to say it's extrapolation? Well, when the data is outside, or when you're asked for a value outside the domain, it's less reliable. So it doesn't mean it's garbage. It just means that you can't guarantee that it's good. All right. So when it's extrapolation, it's a little bit less reliable because the further away you are from the data set, who knows, maybe the trend changes and so on. All right. Whew. All right. I don't think there's anything else with that one I needed to mention. For a second, I was thinking of something and it escaped me. So if it comes back to me, I'll mention it or hopefully we'll talk about it in class. All right. Let's keep on moving then. Oh, I know what it was that you can have the calculator do the value for you. If you go back up to the graph, I could have gone to the table and looked at x equals 20. That was the thing I was thinking of. And so right there, there's 36.35. Or I can go to second trace and ask for value, and I can type in 20. The only limitation to this is it has to be on the screen. So right here, it's going to say invalid because if I look at my window doesn't include 20. So I would have to make sure that I'm only asking it for values that fall within that window. So if I go back to my graph here and I say, okay, what's happening at like 35, which is in the window. So if I go second trace and then ask for what's going on at 35, it would have, second trace 35. It would have no problem telling me the answer right there. So that's a really handy thing to be able to use that second trace and have it evaluate for a specific value. But it's only good for the values on the screen. So you either have to change the window or you just do it by hand the way that we did it. Here we go. I knew I was thinking of something else. All right. Last page, last example. All right, we got Vern here. So it says Vern created a website for his high school sports team. He has a hit counter on the site that lets him know how many people have visited the site. The table shows the number of hits the site received each day for the first 2 weeks. Use your calculator to find the linear regression model and then predict how many hits there's going to be on day 15. So you're going to create the model and then use it to predict a final answer here. All right. First things first, we have to get all of this data into the calculator. So days, that's my independent. That's my X, and therefore my L1. The hits, the number of visits to the site, that's dependent on basically how many days it's been open. So that's my L2. Right. So into your calculator, go to Stat, Edit, and now remember, go up, highlight L2, hit clear, hit enter. Hit clear, hit enter. All right. Give you a second here to enter this stuff in. And I would strongly suggest try it on your calculator. Half of the skill is knowing how to run through and do it yourself. Watching me do it, not going to be as helpful as you really doing it yourself. All right. So I'm going to hopefully not make any mistakes here. Let's see. All right, so I've got all my data in here. Hopefully everything went in correctly. And now what we need to do, if you need more time, pause the video, is I want to be able to create a scatter plot. So first things first, let's go to Zoom Stat. So Zoom 9 will change the window to what I forgot to delete the last equation. Let me get rid of that. So get rid of that. Now go back to your graph. All right. Think about what we got going on here. Along the bottom is the number of days. So we know that went from 0 to 14. And then over here, the number of hits to the site. So if I kind of sketch it, again, it doesn't have to be perfect. It's kind of doing this, kind of going up here, close enough. All right. Don't overthink it. Right. But I would say in general, you can kind of see that there's a trend going up and to the right. So it looks like it's linear here. So from here, what we need to do is our linear regression. So again, stat, calculate, and then for choice 4 is that lin reg ax plus b. So stat, calculate, choice 4, go all the way down and hit enter. If you have an older model calculator, the directions on the last page, you do have to sometimes enter things in a little bit differently. So remind me to help you guys with that in class if needed, right? So write it down. We're going to go, it doesn't say where to round. So let's try to keep it maybe 3 decimal places nearest thousandth so that it keeps us nice and accurate. So we have 2.409 in that regard. X plus 11.225 if we round it to the nearest thousandth here. All right. If you want to keep it more exact, that's fine too. So that's the first thing. Use the calculator to find the linear regression model. All right. This would be the linear regression model. How strong is the regression? Well, the R value is 0.79. So it's definitely not perfect, 0.794, but that's still good. Anything between 0.5 and 1 would still be considered a really strong correlation. So what we're saying here is there's a strong positive correlation between the number of days that the website has been open. I'll say has been online. And the number of hits the site has received or has gotten. All right. So that's the strong correlation between the how long it's been open and how many people have gone and visited. All right. The last part, predict how many hits there's going to be on day 15. All right. Well, day 15 is an X value. So on day 15, oops, sorry, I'm almost off the page there. Let me slide this guy up. On day 15, that's X equals 15. All we have to do is find the corresponding Y value. So you can use it right on the home screen, 2.409 times 15 plus 11.220. You can, if you want to, go into the Y equals. You would have to type that equation in. Don't forget that. So I can go 2.409x plus 11.220 so that I can see it. And then if you'd like, here's where you could do second trace value, and I could type in 15 here, right? And since 15 just sneaks in on the screen, it'll do the work for us. So you can do it either way. If I zoom in a bit, hopefully you can read that a little bit better. The value I'm coming out with is 47.355. But since it's the number of hits, we could say about 47 hits is what you should expect on that day 15. So it's just a prediction. It's not a guarantee, but that's, oops, sorry, super zoomed in there. That would be your expectation. So you're just looking at the trend to make predictions. Nothing about it is a guarantee, but that's the whole point. It's a trend. This is what we would expect. All right, guys, don't forget to go finish by answering the post video question. Thank you so much for watching.